Hey students, this is the part 2 of the video where we're going to do where we have an oblique asymptote. We know it's oblique because the degree of the numerator is 1 bigger than the degree of the denominator. If it was more than 1 bigger, it would be a nonlinear asymptote, which would be weird. So we're not even going to go there. All right. Let's see here. So what do we got to do? Well, it would be good to factor this. The denominator is x plus 5 and x minus 2. The numerator, it's not totally clear how you do it, so I'm gonna set this to ask. So we're just gonna go up here and put it in there. So just the numerator, x cubed minus x squared. Oh gosh darn it. I'm having problems here. Okay, x cubed minus x squared minus 14x plus 24. Alright, so if we go to the table, we just check numbers that divide 24. And so the rational root theorem says that the rational root's numerator would divide 24 and the denominator will divide 1. So the denominator is 1. So we'll just check numbers that divide 24. That's all we need to do. So negative 1 and 1. 2. So x minus 2 is a factor because 2 sent it to 0. Negative 2. 3 works. Okay. Negative 3. Divides by 4. Negative 4. There it is. So it's fully factored. We found 3 factors. So we're done. Okay, so that's one form that's useful. The other form is the divided form, where we actually do the division. But it was good to do this because we noticed that we have a cancellation happening here. So the domain of R, in this case, we exclude any number that's in the denominator down here. So negative infinity to negative 5, and then negative 5 to 2, and then 2 to infinity. That's important. So since 2 is not in the domain of this, we can cancel these. It's never 0. Okay. So when those are canceled, it reduces actually. I'm going to go ahead and expand that back out now. So that's x squared plus x minus 12 over x plus 5. Okay, so this is like the reduced form of it. So if we want, now we can actually do the division here. So we send the 0, negative 5 into 1, 1, negative 12. So synthetic division gives us that. So this thing can actually be written as x minus 4 plus 8 over x plus 5. That is also a useful form of writing the thing because this now here gives us our oblique asymptote. Okay, so we now, with all those different ways of writing it, we have everything we need. We can talk about the mid behavior, and we can talk about the end behavior because that form helps us get that. Okay, so let's get the end behavior is just that we have an oblique asymptote. Y is x minus 4. From this form, we can see that we have a vertical asymptote, x equals -5. So those are all the asymptotes. What other kind of mid-behavior do we have? These factors up here are giving us zeros, so zeros, 3, 0, and -4, 0. There are no holes, well, no, there was a hole. Right, there was a hole because of that, so we should have mentioned that. So that's when x is 2. What would it be in here? It would be 4 plus 2 is 6 minus 12 is -6 over 7. So that's our hole. What else? Vertical asymptotes is zeros, holes. We need the y-intercept as well. So that's the ratio of the constant terms, so -2.4. There. That's the full analysis that we need in order to build our table. Okay, so from this, we can build our table. So we just look at these x coordinates and just put them in here in order. So we always kind of want our vertical asymptote in the middle. Okay. What the real middle of it will be is where this asymptote crosses this asymptote. So the x coordinate will be -5, so the y coordinate will be -9. That point we want right in the middle of our grid. So it makes sense to put the vertical, if there was more than one vertical asymptote, I would just kind of list them in the middle. Okay. Is there anything more negative than that in our x coordinates? No. So let's list this 0 here. It's always kind of a good idea to get kind of close to your vertical asymptote. So I'm just going to find an intermediary there. Probably you're going to want one right next to it on the other side, just so we can see it how it's approaching that vertical asymptote. Okay. All right, what else? So what's the next? Is there any other negative x's? That one, no. So then it'll go 0, 2, 3. All right. And at 3 we had a 0. 2, this was a phantom point. So what is 6 divided by 7? Okay, so this is, so actually it was negative, right? So it's -0.86. Right, I'm just going to put a dotted thing around that just so we remember it's a hole. Our y-intercept was -2.4. We're gonna want maybe one more point up there just for some more end behavior. All right, now we want to go more or less the same distance away here. So it's a good idea to just pair all these up. So one backwards, one forwards. 0 is 5 away, so we'll go here, then 2 more away. Okay, that'll give us a roughly symmetric graph with the vertical asymptote right in the middle. Right, we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and they're all spaced the same, so that ought to be nice and symmetric. So to get these other numbers, sorry, we just put these in the table. So this function here is just the numerator of this, right? So we need to put it over the denominator. So I'm just going to insert, well, let me show you another thing you can do. You can just put the denominator as a function if you want. And then you can make a third function that's the ratio of them. So y1 variables, y variables function y1 of x divided by y2 of x. Okay, so it's just this over this. So that's the one we want. I'm going to turn the others off because I don't want to see them. They just need to be in memory. If you unhighlight those equals, then they're not like actively loaded. So now if we go to our table, we can just look at all these numbers and see if everything comes out the way we want. So 4, 3, 2, 0, negative 4. Let's move this back up. Negative 4, negative 4.5. Negative 5 was our error, right? Negative 5.5. Negative 6. Negative. Negative 12 is all we can fit right now. Okay, so the 4 gave us a 0.89. The negative 4, so all the other numbers match up the way we expect, yes. And then this one gave us a 7.5. And we get a negative 25.5. Negative 6 is negative 18. Negative 15.6. Negative 17.14. So a couple more. Okay, so we have our table. Now we can graph. Alright, so the way I've set this up, since I've put my vertical asymptote right in the middle, I'm going to be pretty sure that the two asymptotes will intersect right in the middle. So negative 14 to 4, how about I just go negative 16 to 4? That'll probably be good. Should be able to see that pretty well. Now, the smallest value in my table appears to be this negative 25.5. And the largest is the 7.5. So if I go negative, I like doing multiples of 4. So why don't I go negative 32 to 8? Okay, so I'll just go by by 4s. Negative 12, negative 16, negative 20, negative 24, negative 28. That's good enough. That'll fit everything. And then 4, 8, negative 12. Okay, pretty happy with that grid. So probably should throw in some extra integers. We will be plotting individual integers there. We don't need to do it with the other one. Okay, So let's start here. Well, let's first graph our asymptotes. So x is -5 is right here. Okay, so we have that. Now this one is a line with slope 1, y-intercept -4. So if you put 4 in, you'd get 0. So it kind of does that. We know they intersect at -5, -9. So that would be right here. Looks pretty good. All right. Now that we have those in there, now we can plot these points. It's going to help us out. So 4, or no, let's start down here. 8 negative, that's like -19 essentially. So that's right about there, and we need to go to -14. So it's just under that thing. You know, actually, I messed it up a little bit, but if you were at -14 here, you'd be at -18, which would be above this number. Right, so really the vertical asymptote's off, or the asymptote is off a little bit. So, okay, -19, it's right under it, just barely. Okay, it's kind of hard to graph that perfectly. All right, and then -18, -13, -17. So again, all of these are just basically right under the asymptote. -10 gives us -15.5. So that's 12, so it's right under that. Still very, very close to it. -6, -18, so it actually went down now. So something changed. Okay. Then -5.5 gives us -25.5. Alright, so that's giving us some pretty good behavior there. It would be nice to have one more point. So at -8, what do we get? -14, 6, 7, so that's about right there. Okay. From there, it should have gone down a little bit. So down a little bit. Whatever. That's basically what it's doing. Don't have to be super perfect. Alright. So it should look more or less the same on the other side. -4.57.5. So that's almost up to the 8. -4, 0, 0, -2.4. This is a hole right around -1. Three is a 0, and 4 is just barely above that thing. So we can see what it's doing. Okay, so it's doing that. So we should see all of that if we put it in this window. 4. Let's get 4x4s. So -28 to 12. Also scaled by 4s. You should kind of see this. We're not going to see the asymptotes, but we'll see the curve. good. So let's just throw that asymptote in there. X minus 4. And on any kind of quiz or anything, I would give you a grid so you won't have to screw around, but it'll be easier to figure out where points go. Okay, looking good. Now, slightly more complicated situation. It'll look very similar, but it's a little bit different. Okay, so again, this you always start by factoring. So -5, -2 this time. And then up there, who knows? You have to use this thing. So go over here. Let's clear that one out. X to the third plus x squared minus 17x plus 15. Might as well change this one to x squared minus 7x plus 10. Alright, so we're only really interested in this numerator right now because we want to see when is it 0. This don't need anymore. Alright, so let's go to our table and try numbers that could divide 15. So 1, that's easy. -1, 2, -2. Oh, that doesn't even divide 15. That was stupid. 3 works. -3, 5, -5. So -5 gave us a 0, so that's an x plus 5 there. Okay, factored. So nothing cancels, so there's no whole. 2 vertical asymptotes this time. So we need to get it in the form where we can see that. We know there's going to be a oblique asymptote there, but what is it? Well, we just choose one of the zeros here. It doesn't matter which one. I'll just start with the 2 and send it into this. So 1, 1, -17, 15. I think that's -7. Okay. So what is it that this is? What is it we found? Well, what did we do? We divided this numerator by this linear factor and got this stuff. So we still have the x minus 5 down there. Okay, that's not changed. But the x minus 2 got sent in. So the result is, now this is degree 1 lower. So that's x squared plus 3x minus 11. And this is the remainder. So it's minus 7 over the thing we sent in. Okay. So now what I can do is I can sort of just take this polynomial part here and treat it as a singular object. And so I'm going to take the entire x minus 5 and divide it across both of these terms. That's how this is going to work. Now to do it into the first one, we do synthetic division again. 1, 3, -11. And we end up with that. So now that we've done that, this divided by this is x plus 8 minus 29 over x minus 5. If I took this thing and divided it by that, I'm just putting that other thing in the denominator. So minus 7 over x minus 2 times x minus 5. Alright, so now what our polynomial part is this oblique asymptote here. This stuff is just a bunch of remainder stuff that we don't care about. Doesn't really help us do anything. We could combine them, but there's really no reason to, because we found this. So now we found everything we need. So let's just kind of figure out what the results of this analysis are. So again, we want the mid behavior, and we want the end behavior. So we just found the end behavior. We know this is our oblique asymptote. Our mid behavior, so we got a vertical asymptote. Well, there's two vertical asymptotes. There's x is 5 and x is 2. There were no holes. The x-ints, these three things, so it's the point 1, 0, 3, 0, and negative 5, 0. And the only other thing is the y-int. That's 0, comma 15 over 10, so 1.5. There. So now we'll get a table. And what I do here is I put my vertical asymptotes kind of in the middle with some points in between. So are there any numbers in between 2 and 5 down here? 3 is. So we might as well put 4 in there as well. We're going to need it. Alright, I like to get kind of close to that vertical asymptote. So I'm inclined to put some numbers hugged up against each of them. Alright, 3 was a 0. Okay. Continuing down, we get another 0 at 1. Then we get our y-int. Then way down here at negative 5, we get another 0. Okay. So let's go out further, maybe out to negative 12. Alright, so if we, off this vertical asymptote, we went down 14. So if I go off 14 off this guy, I'd be at like 17. So I'll just go out to 16. Okay. Then let's just choose some more points that are out there. So maybe 12 and 8. That seems reasonable. Alright, and I've left space in here in case we need more, but I think we're going to be good. There's only one way to tell, though, and that's to just start doing this. So now I've already fixed all this. I'm just going to disable this one and enable this one. So 16, 12, 8, 5.5. Error for this one, I hope. 4.5. 3 should give us this, or did we do 4? 3 should give us a 0. 2.5. And then 2 is an error. and then 1.5. Okay, so let's fill this in. 2659, 2404, 2528. 5.5 gave us 60. Wow, that's a big one. 67.5. Then negative 39.9. Then negative 13.5. 0, 4.5. 2.5 gave us 4.5. Error negative 2.779. So we'll just go back to the top, I guess. Now we're at 1, just to see if that worked. 0, negative 5, negative 0, negative 12. What is this? Negative 5.74. All right. Good enough. So we're going to go from negative 12 to 16 on the x-axis. All right. On the y-axis, we get this really big number here. So I need to be like pretty high up there. I guess I'll go to 80 and then down to negative 40. Then I should see everything. So I'll just go by 20s here. Okay, that looks pretty good. Now, let's put our asymptotes in. At 5 we have one, so let's refine this a little bit. Okay, that's good enough. So at 5 we have a vertical asymptote, and at 2. Cool. And then our oblique one is this. So y-intercept of 8. So if that's 10, each of those is 10. So a little bit below that. And then it'll intersect at negative 8 over here. So it's going like this. Didn't make that very straight, but whatever. That's more or less how to set up your grid. I knew that this midpoint in here would be right in the middle by the way I set that up. So, negative 12, negative 5.74. Let's just see. If we were at negative 12 here, we'd be at negative 4. So we're underneath this asymptote, but not very much. At negative 5, we are at 0. At 0, we're at 1.5. So that's barely off the axis at that level of zoom. At 1, we're at 0 again. And then at 1.5, we're at negative 2.79. So not really that far down, but whatever. We know what's going on there. It's doing this. Now in the middle of those two vertical asymptotes, at 2.5 we're at 4.5. So that's still under here, right? Because at 3 we impacted the x-axis. At 4 we were at negative 13 point something. And then at this 2.5 we were at 4.5, so it looks like it positive 4.5, that's wrong. Okay, so I believe what happened is it's going to do this kind of thing. All right. Then we hit that asymptote. Now we're way up here at 67.5. And that was at 5.5, and then we're out of 8. We're up at 25 something. And then at 12 we're at 24. Is that what that is? Yeah. So it didn't really fall much. And then we rise a little bit at 16. We're at 26 point something. Alright, so I think we see what's happening over here. I'm doing this. So I believe that is kind of what we should see in that window. Negative 12, or yeah, negative 12 to 16 by 4s, negative 40 to 80 by 20s. Yeah, it's having a hard time graphing it in there, but let's just zoom in a little bit. So we won't go out so far. Let's shave a little bit off that. Let's go negative 8, maybe to 12. And then let's go negative 20 to 40. And we just go by tens this time. Should look a little more interesting. I may lose some of this though, that's okay. Alright, let's put that asymptote in there, that'll help. X plus 8. That looks right. Okay. So that's the idea. That's how we graph these things. It's the art of it is filling in this table, really, choosing your points wisely. You have to have all of this mid-behavior stuff in there, but to really describe that mid-behavior, you need points around it. Like certainly you need points in between your two vertical asymptotes to see what that mid thing is doing. Yeah. Okay, thanks for watching.